Welcome to the Entergy Central PowerTalk titled Digital Transformation in Existing Nuclear. I'm Audra Drazga, the Vice President of the Entergy Central Power Industry Network. Entergy Central is a community platform with a goal to help professionals in the industry to share, learn, and connect in a collaborative environment. Our Power Talks are short 20 to 30-minute pre-recorded video or audio sessions bringing together industry experts to share their expertise around a topic that we feel is of interest to the industry and our community members. We invite Entergy Central members to interact with the Power Talk discussion by using the comments section to ask questions, share your feedback, or add your own insights. If you have questions, the Entergy Central Community Management Team will do our best to gain answers from the presenters and/or other community members. And now, I'm pleased to share with you today's Power Talk.
For the electric power industry, digital transformation can be seen as a conversion of all forms of data, such as analog signals and paper-based processes, to digital formats to allow enhanced data analytics and automated workflows throughout the enterprise. For nuclear utilities, digital transformation can span topics from updating nuclear power plant controls to replacing paper-based warehouse inventory controls with smart tags and tablets. Digital transformation can also be a key part of plant modernization to reduce operations and maintenance costs while at the same time preserving safety and reliability. I'm Rob Austin of EPRI, here today to talk about digital transformation with Andrew Barritt, Deputy Engineering Director at Kernkraftwerk Leibstadt, or KKL Nuclear Plant in Switzerland, and Dillon Allen, Senior Manager at Entergy Nuclear. Hello, everyone.
Hello, Rob. Hello, everybody.
Hey, Rob. How are you doing? Good to see you again.
It's good to see you guys. So let's start with Dillon. Dillon, how does Entergy Nuclear view digital transformation as valuable for its fleet?
Well, we absolutely view it as a key part of our strategy as we modernize our fleet. It's helping us in lots of ways, from obsolescence issues to being able to do more with less. So ideas like robotics, drones to be used in place where we had to have humans, or just replacing components that were designed in the 60s and 70s with analog parts that now are no longer available. So it's a big key for us.
And how is that value translated to the enterprise? Is it, what is the real benefits that you see?
Right. So first of all, from the obsolescence issues, when and if we have equipment reliability issues, you could look at the recent IAR talking about the probability of one. When something fails, what do you do about it? Well, there's some things that we've had to reverse engineer over time to make an analog equivalent to what we had in the 60s or 70s. So as we can replace those items with digital controls that are ready to roll, we can minimize the risk to continued operation of the plant. So that's one aspect. With things like robotics and network capability and drones, that really allows us to reduce dose and potentially to reduce supplemental support that we may need. Imagine an outage where you could do all of your surveys with robotics and communicate that real time to your workforce, which greatly reduces schedule impacts and personnel impacts. So there's real money associated with digitizing the workflow in the plant.
Well, that's great. Andrew, what has been the most valuable digital transformation at KKL in Switzerland? Has it been as one single project or an overall integration of digital thinking and realization into the organization?
Coming to think of it, I'd say definitely the second, the integration of digital thinking and realization into the whole organization. If we look at, for example, our corporate, which is Axpo, it's a large energy supplier in Switzerland. Axpo has initiated what they call a Nuclear 4.0 program a few years ago. And this is basically all about digitization, new technologies, innovation, and gives a very fertile ground for development of ideas, initiatives, and projects in the digital world. On the one hand, in the plant itself, we are transferring from analog INC, the old style that you had many years ago, to digital technologies. We started on non-safety related systems, learned a lot about implementation, how to do it, how to set it up. And now with this experience, we're going into now safety related systems. We'll start in 2023 and continue 2024 on safety related systems. On the other hand, we're using digital technologies such as robotics, digital visual data acquisition and analysis to support plant operations. Just yesterday, we were informed about a new project where we want to basically upgrade our outage planning, where we will be using more digital, I'd say, databases, backgrounds, and so on to make the work more efficient. Furthermore, if we look at the whole Axpo company, we have bi-monthly calls of something we call the Digital Transformation Network, where people get together in calls, and basically the participants, they present their new ideas, their results, what they've been going through to the whole team, basically so that everybody can see what's going on. And I'd say it's also a certain inspiration for people to come up with new ideas if they see what others are doing. I'd say definitely the second, just, saying digital is here to go, get involved in it and bring up your ideas.
So for the Digital Transformation Network, that its own group, or is that like a combination of groups and personnel that already had other roles?
It's not an own group. It's basically the Digital Transformation Network is bringing together people from the whole company. That can be somebody who's in grids, can be somebody who's in hydropower, who's in nuclear, all over the company, and they just are in this group, which is called the Digital Transformation Network, and basically join. No, it isn't a special group. It's just everybody who's involved in this.
Yeah, and I think through EPRI R&D, we've shown that a lot of digital transformation has already happened outside nuclear. You mentioned the grid, also non-nuclear generation in many cases has moved ahead with adoption of digital technology than nuclear. So I think it's very valuable to include those personnel in the transformation at nuclear plants. All right, back to Dillon. What have been the major lessons so far learned from implemented digital transformation projects?
I'd say the largest lesson we've learned is that you have to really remain intrusive with your vendors throughout your supply chain and maintain technical conscience of the organization. It can be difficult because many of the things that we're doing with these digital transitions are were formerly analog. There were circuits that had varistors and thermistors and all of these piece parts that you could go see and you could predict the specific behavior of, and it was well understood. And now some of the control systems that we're working with, they have a bunch of digital input output, and it's somewhat of a black box what's going on into what used to be multiple cards and circuits, and it predict the behavior of a card. Now 100 things are all being done in one small black box, and so how that box is wired, what the control circuitry does, it's important to understand, just as important as the analog ancestors. So we are becoming much more intrusive with our vendors from an engineering perspective in the design phase, and that's a major lesson.
What are some specific ways to become intrusive? Because I would imagine with the black box, in many cases, the vendor has intellectual property that they'd like to protect.
Intellectual property is a challenge, but you have to have a partnership mentality with your vendor, and your vendor has to have that mentality as well. And you go into the agreement with that viewpoint. We didn't necessarily do that initially. So now we've learned, and we're opening up a little more with our vendors and asking ahead of time to engage and look deeper into it. And also some expertise that we may not have had that we needed to bring in from other areas of engineering, not just traditional electrical, mechanical, civil, right? Some more digitally expert parts of the discipline.
So I think similar to involving others in the utility with outside nuclear digital expertise, a lot of digital expertise is with the supplier vendor community. But I think also you're saying it's very important to involve them early, perhaps even before as part of contract negotiations, and make sure they understand the level of intrusiveness, as you put it, that's going to be expected.
My son shows me frequently things that are memes on the internet, and one of them is TLI5. Explain it like I'm 5. You have to dig and pull the thread and pull the thread and pull the thread until you truly understand. You have to start out with that lower level of understanding and then grow your level of knowledge in the organization.
That's great. So kind of in that same thing, it sounds like this doesn't happen overnight. So going back to Andrew, in which time frame does the board of directors and the senior leadership at utilities expect a return on investment from digital transformation projects?
I think this, and also the expectation is this depends on the size and scope of the project. For example, what I talked about before, this change from analog to digital I&C may take a few years to show a return on the investment through reduced maintenance, more stable operations, and simplified testing. However, if you can just avoid one large power down or even an unplanned shutdown with new equipment, with the digital equipment, I think the return accelerates considerably. And that is something which is also considered in the risk evaluation of a large project. On smaller projects, such as the use of robotics, the return can be very fast. At Expo, we use a robotic walker for RP surveys and visual inspections. And if you can perform a survey where otherwise you would have had to depend on, say, a critical resource, maybe an HP technician which wasn't available or something like that, then the return of investment can be nearly instantaneous.
Yeah, certainly if you're able to avoid sending personnel into the field, into the plant, in addition to the return, there's some safety benefits. I wanted to go back to the avoidance of outage. Many nuclear plants, the nuclear industry as a whole has an excellent reliability record. Plants simply don't trip offline, particularly for equipment failure reasons, that often, and this is a major success of the industry. But does that make it difficult to prove to senior leadership that then you need this additional digital technology to improve performance?
I would not say only that. It's if you can prove that basically you will be able to run the plant more reliably, because let's be quite frank, the analog I&C equipment we installed that 30, 40 years ago. It's basically, we're running a technical museum there. And this equipment will sooner or later fail just due to age effects and so on. And if you can say, look, this new equipment, it will probably have some challenges in the beginning before it operates absolutely reliably, but you will certainly avoid problems that you would have with the older equipment as time passes, as time goes by, as aging effects set in.
So it's a case where the past performance of the plant may not be reflective of future performance simply because of the aging of a lot of the existing equipment.
Right, yeah, certainly.
All right, well, Dillon, did you have any concluding thoughts for our audience on digital transformation and nuclear power?
I just want to mirror what Andrew said. The idea of reliability of things that were designed 40 years ago and may have been sitting on the shelf for that long, that's the story we have to tell. It has been successful within our company. There was even a time when we had a group of engineers who had some internal company fame for being able to reverse engineer some of these old components that manufacturers had ceased to exist. And it was able to keep us moving in an analog world for a while. Those folks are retiring, that expertise started to attrit. And so we are left with fewer and fewer choices for when it happens, not if it happens. So it's not a difficult story to tell if you think about it in terms of when it happens. And so we're looking forward to really exploring the entire breadth of digital transformation where it makes sense for our corporation's owners and our customers and our communities. So we're looking forward to the future.
Thank you, Andrew. Any final remarks on nuclear power and digital transformation?
Yes, digital is definitely the way forward. I mean, if you just look around us outside of our power plants, digital is transforming our lives, and it's time maybe to catch up with digital transformation also in our power plants to make them more reliable, to prepare them better for the future. And something that Dillon just mentioned with these engineers who knew how to reverse engineer old analog equipment. We're getting new people into the plant who have grown up in a digital world, and we have to basically, how shall I say, keep these people interested in what we're doing by showing them that we are not running just old stuff, that we're also moving forward. and that is a great help. We just, at the moment, we're also looking at installing Wi-Fi in the plant, using that to collect data. And a lot of the people have asked me, well, how should we start on that? And a lot of the questions we have, initial questions, we find EPRI products which can already help us get on the way there. For example, there's a wireless sensor survey, how to use wireless sensors. There's a how to set up a Wi-Fi in the plant with leaky wires and distributed antenna systems. So I can then point our people in the direction and say, look, a lot of the groundwork has already been performed by other people. Basic research has been done. Look at that and then come with, how shall I say, specific questions that then we can start answering, we can look into, but don't try to work on the basics if somebody else has already done all that. So that's a great use of EPRI products we can do there.
Thank you, Andrew, and I want to thank our panel, Andrew and Dillon, today, and I'd like to thank our audience for your attention in this Power Talk. For more on nuclear plant modernization digital transformation, be sure to visit our site at nuclearplantmod.epri.com for tools and news. Thank you.